Very good day to my lecturer. I'm Govindan S. Purushothaman, matrix number CE210192. So I'm going to talk about, and also you can say I'm going to present about question 1. So for question 1a, we should solve the equation that is x power of 3 plus y power of 3 minus 2x power of 2 y equals to 0. So for the equation, we should do d or dx in the bracket x power of 3 plus y power of 3 minus 2x power of 2y is equals to 0. d or dx plus x power of 3 plus d or dx in bracket y power of 3 equals to 2d or dx x power of 2 y equals to 0. So 3x power of 2 minus 4x y equals to 0. So hence we get 3x power of 2 minus 4xy over 3y power of 2 minus 2x power of 2. Second, d or dx equals to in bracket x power of 3 minus plus y power of 3 minus 2x power of 2 in y equals to 0. So for that, d or dy x power of 3 plus d or dx in bracket y power of 3 minus negative 2d in bracket x power of 2y over 2 dx. So we get 0 plus 3y square minus 2x square equals to 3y square minus 2x square. So as you can see, this is the manual calculation method, and for the so far I use symbol app. So for that, as you all can see, this is that I put the input here, and this is the solution for that. Moving on to the second question. For question 1a, Roman 2. So sine power of x minus 5 sin x cos y plus tangent y equals to 0. So to solve that, d or dx in bracket sin x sine power of 2x 5 cos y d or dx sine power of sin x plus d or dx tangent y equals to 0. So 2 sin x cos x minus 5 cos y cos x equals to 0. So d or dy in bracket sine power of 2x minus 5 cos y d or dx sin x plus d or dx tangent y equals to 0. So equals to 0 minus 5 sin x sin y plus sec power of 2y equals to 0. So dy or dx equals to 5 cos x cos y minus 2 sin x cos x over 5 sin x sin y plus sec power of 2y. So this is the manual solution method, and this is the solution I use symbol app. So this is for question A, Roman 2. So this is the way, and this is the answer. So moving on, question 1b is to prove that is equals to 0. Okay, so what I did first is dz or dx x minus y in bracket y minus xy over in bracket x minus y power of 2 is equals to negative y power of 2 over x minus y power of 2. So as you can see, after doing all the solution, so d power of 2z over dy power of 2 equals to x power of 2 times in bracket negative 2 in bracket x minus y power of 3. So now x power of 2 d power of 2z over dx power of 2 is equals to positive 2x square y square in bracket x minus y negative 3 power of negative 3. So what we get is x power of 2 d power of 2z is over dx power of 2 minus y power of 2 d power of 2z over dy square equals to 0. So hence it's proof lah. So this is the manual calculation method, as you can see. And for that I use MATLAB, but sorry I couldn't open my MATLAB now. So this is how I did in MATLAB. I sims x, y, z, equation of z, and I simplify the differentials of x, z, x, and 2. So I derive this one, and I get f1 is 2 times y power of 2 slash x minus y power of 3. So for f2 I simplify the differential of z, y, and 2 and derive that. So I get 2 times x power of 2 slash in bracket x minus y power of 3. So I did a mistake here. There's an error in this f equals to x power of 2 times f1. It should be negative here, but I put equals. So I did back the equation and I put negative here, and I get the answer that f is equal to 0. So that's all. Moving on to question 1c. So this is the tree diagram that you should draw. So this is the manual way that I draw the tree diagram. And for question 1c, this is to prove that fr is equals to fx cos q, fy sin q. So for that, as you all can see, that is the way I did. And finally, I proved that fx equals to cos q plus fy sin q. So I proved this is the word method. And for that, this is the symbol lab for question 1C, Roman 2. These are the steps, as you can see. Yeah, and I print screen here. And that's all from me. Thank you so much.
So a very good warm greetings to our lecturer. My name is Devendra Nanalaki Perumal, and I'm from Faculty Kejuruteraan Electronic Engineering, and my metric number is CE210201, and I would like to continue our group assignment, which is question number 2. So question number 2, as per the question 2a stated, find the volume under the surface Z equals to 3x3 plus 3x 2y and over the rectangular R x, y, and 1 is not more than x and not more than 3, and 0 is not more than y and not more than 2. So as you guys can see in here, this is the manual calculation that I did to find the volume. So I use double integral first, which is integral y, integral x. We can see integral y we have 2, 0, and integral x we have 3, 1, and I just substitute the value which is given by the z, which is 3x power of 3 plus 3x power of 2y. So I've been stated here, and by this I've calculated the volume, and I've got 172 over here, 172 volume, and I've jotted down in Word as well. To prove my calculation value is right or not, I've checked with it via the software calculation, which I use is Symbolab. It's free and it's online. So I've just stated the integral 2, 0, integral 3, 1, 3 x power of 3 plus 3 x 2 y dx dy, and I've got the 172 volume, which is exactly the same answer I got by my manual calculation. Moving on to the next one, which is question 2b. Find the surface area of the portion of the paraboloid given by the equation z equals to 1 minus x 2 minus y2, that is above the xy plane. I did my manual calculation. So which is to find the surface area, must use the integral, double integral first, as I stated there, and then I have assumed when x equals to 0, x power of 2 plus y power of 2 is equals to 1, and then I calculated the polar coordinate, which is x, if x equals to 1 cos theta, y equals to 1 sin theta, and x square plus y square is equals to r square, and r is 0, not less than r and not less than 1. For theta, 0, not less than theta and not less than 2 pi. So I've calculated the surface area, integral 0 2 pi integral 1 0, and then in punca kuasa root square 1 plus 4r square dr d theta, and then after calculating this all, I've got my surface area, which is 5.33 unit square. To prove, and also stated in my calculation solved by Word, so I get this graph. So to prove my calculation is correct or not, I've tested in Symbolab as per I tested before during the question 2a. So it stated 5.3301 decimal, which is exactly the same answer I got by my calculations, 5.33 unit square. Moving on to the next one, which is question number 2c. Question number 2c stated an ellipsoid is given by the equation 4x2 plus 4y2 plus z square is equals to 16. As per the Roman 1 question asks, sketch the three-dimensional 3D graph of an ellipsoid and its projection on a suitable plane. I did my manual calculation, which is 4x square plus 4y square is plus z square is equals to 16. So first of all, I've just shifted this 62 and I divided by everything, which is when you divided 4x square over 16, you'll get x square over 4, and when you divided 16 to 4, I'll get y square over 4. To if you divide 16 to z square, I'll get z square over 16. I've just transferred this 16 towards this thing. So for the first one, when z equals to 0, x power of 2 over 4 plus y power of 2 over 4 equals to 1. So I get this graph for this suitable plane for this. And if when y equals to 0, x power of 2 over 4 plus z power of 2 over 16 equals to 1. So I get the suitable plane for this, which is the x-axis got 2 and the z-axis got 4. The next one, which is when x equals to 0, y square over 4 plus z square over 16 equals to 1. So our y-axis will be 2 and our z-axis will be 4. So this is our center semi-axis length. Our x-axis is here, which is 2, and our z-axis is 4. Our y-axis is 2. So I have jotted down my manual calculations that I did in Word. This is all the words. Moving on to the next one, which is question 2C, Roman 2. Find the volume of ellipsoid using triple integrals by changing it into cylindrical coordinate system. This is my manual calculation, and when theta is equals to 0 more less than or equals to theta less than or equals to 2 pi, r equals to 0 less than or equals to r less than or equals to 2. So I just use z square is equals to 16 minus 4x square minus 4y square. Z square is equals to 16 minus 4x square minus y square. So you guys can see I've used the same formula for the volume like the previous one. The integral 2 pi 0 to 0 integral, and then I got this is for z square, so I've just substituted. I just want z, so I shift the power of 2 towards here, so it's changed the root of 16 minus 4r square. So you guys can follow these steps, and after all I got 33.51 unit. So to check my answer whether it's correct or not, I've proved it in my software calculation in Symbolab. So it's stated 23 pi over 3, which I get here 32 pi over 3 unit, which will be the 33.51 in decimals unit square. And this is how I did my manual calculations, software calculation towards this question 2. This is for question 2A, and I got 172. And this is for question number 2B. I got 5.33041. And this is for question 2 Roman 2, 32 pi over 3. So this is how I did everything for question number 2. And that's all for now by me. I will thanks for this opportunity, and I would like to pass my assignment to my following member. Thank you.
Okay, Assalamualaikum and very good evening to lecturer and fellow friends. My name is Muhammad Faris Firdaus bin Saru, number matrix CE210211. Okay, so today I am going to explain manual calculation for task 3. For A question, find the mass of a wire in the shape of helix RT equals to cos theta t I plus sin theta tj plus 8tk. 0 is smaller than t and t is smaller than 1, where the density of the wire is pxyz equals to x square plus y square plus z square. So for xt equals to cos theta t I cap plus sin theta t I cap plus 8t k cap. I got the answer for xt equals to cos theta t, yt equals to sin theta t, and zt equals to 8t. So I use length formula for ds equals to square root dx over dt square plus dy over dt square plus dx over dt square dt. And the answer for dx over dt equals to negative theta sin t. Answer for I dy over dt equals to theta cos theta t. The answer for I dz over dt equals to 8. And the final answer for ds equals to square root theta square plus 64 dt. And then we have to integrate for m. And the mass of the wire is the final answer, which is 67 over 3 square root theta square plus 64 units. We move to the B question. Given the force field F x y z equals to x square plus y square I plus 2xy j. So the first step I do is curl, as you can see in the table, and the final answer is k 2y minus 2y equals to 0. F is conservative force field. For the 2 Roman question, find potential function flux. Flux equals to x squared 3 over 3 plus 2xy square plus constant. So we move to 3 Roman question. Hence, evaluate the work done by the force field F on a particle that moved from negative 2 to 10. So the displacement produced moved from point negative 2 to 10 equals to 1 minus negative 2, 0 minus 2. And then we get 3 2 over 3 I cap minus 2 j cap. And then we have to times it, x squared plus y squared I cap plus 2xy j cap times with 3 I cap minus 2 j cap. So the final answer for 3 Roman is 3x squared plus y squared minus 4xy unit of force. And lastly, for the C question, verify Green's theorem by evaluating both integral. First step I do is integral along the curve y equals to x squared 3 from 0 0 to 1 1, and I get 5 over 6. The second step I do is integrate along y equals to x from 1 1 to 0 0. I get negative 3 over 4. So the required integral is negative 3 over 4 plus 5 over 6 equals to negative 9 plus 10 over 12, and then I simplify it, I get 1 over 12. The other way you can get the same answer is integrate r dn over dx minus dm over dy. So the final answer, x squared 4 over 4 minus x squared 6 over 6 equals to 1 over 4 minus 1 over 6, and the final answer is same, 1 over 12. Okay, so thank you.
Hello, my name is Ederin Sanai and my metric code is CE21010. So here I'm going to explain about question 4 for this project, and this is my manual calculation for question 4A. This is the question and I calculate it. This is the integral, and then I get a 1 per 2 for this answer for 4A. And then I do a simulation for this part. This is my simulation for the 4A FA, and then I type equation, then type as mean S3 uh, multiply by pi equal to S make equal to 2 multiply by pi, and after that I type a value. This is value 2, value 3, value 1 minus value 2, and then I'm going to run it. So the answer is again is 1 per 2 for this question. And then for the manual calculation for part B, this is the question for given 3xi plus 4yj minus yz square k. This is the question, and then I do the calculation, manual calculation. This is the formula in polar coordinate x dy equal to rd. So x equal to 2 cos theta, y equal to r sine theta. So I do the calculation, and the last one answer that I get is negative 23,168 per 3 pi. So and then I do a manual I do a simulation for question 4B. I type a question for this part B, s make equal to 10, s make equal to 4. So after that I'm going to run it, and I get a answer for this part B is negative 2.2251 plus 4. So from that I didn't get a answer for this solution. And then for the 4C, part C, this was the question was given f to x 3I minus 2yj plus 2z square k, and I'm convert it to cylindrical coordinate. So I do all the calculation, then finally I get the answer is 6458 per 16 pi. This is the last answer I get for part C. And then I do a simulation for part C, and I write this question for part C is equal to 1, is make 5, value 1 is equal to integral ft t and 1 and 5. So that this is a display value 1. Then I'm going to run it. So the answer is 64,589 5 per 50. So I got a good answer for that. And then for the part D, for the question 4, this the question that was given f equal to 2 square I plus y square j plus sk. And then finally I get the answer for this question is z minus 0.5. And for the simulation for this part 4D, I'm going to f8, I write the equation, and then do this. I'm going to run it. We get the same as z minus by 1.1 per 2, or it z minus by 0.5. So that is my explain for question 4 for this project. Thank you.